So this video is to finish out our investigation 9. So this is part 2. Make sure that you have your math notebook. Make sure you've got some graph paper. Okay, so today we are talking about inverse variation. Okay, the first part was about direct variation. So our last part is about inverse variation. Make sure you get this definition in your notes. An inverse variation is a relationship between two variables in which a change in one variable results in an inversely proportional change in the other variable. Okay, that's a long definition. Basically, it's the reverse of what happened with our direct variation. In a direct variation, when one variable increases, the other variable increases, or when one variable decreases, the other variable decreases. In an inverse relationship, when one variable increases, the other variable decreases, or vice versa. Okay? A good example is choice C from number 9 in our investigation, which is talking about the speed at which you travel to school and the time it takes to get to school. Okay? So think about it. If you drive twice as fast to get to school, it does not take you twice as long. It only takes you half as long. Okay? So our variable of speed is increasing, but the time it takes us is decreasing. This is an inverse relationship. Okay? So, if a trip takes Adam 2 hours when he's traveling at 60 miles per hour, it would take him twice as long, 4 hours, if he were traveling at half the speed of 30 miles an hour. Okay? So this is the relationship we're looking at here. If it takes us 2 hours and we're going 60 miles an hour, it's the same as traveling for 4 hours at 30 miles per hour. Okay? So if I multiply these together, I would get 120, right? If I multiply 4 times 3 together, I also get 120. Okay? These two are equal, but they are showing an inverse variation. Okay? Using this scenario, to find out how long the trip would take if we were driving 40 miles an hour, we would continue with knowing 2 hours at 60 miles an hour would be the same as some amount of time at 40 miles an hour. Okay? Now go ahead and pause your video and use this information and go ahead and answer numbers 12, 13, and 14. Okay, so on number 12, what was the answer to your equation? You should have gotten 3 hours. At 40 miles an hour, the trip would take 3 hours. Number 13, they ask us to make a function table showing how long the 120-mile trip would take at 60 miles an hour, 40, 30, and 20. Okay? We already know at 60 miles an hour, it takes 2 hours. We just decided 40 miles an hour, it takes 3 hours. We could use our same equation to figure out that at 30 miles an hour, it would take 4 hours. At 20 miles an hour, it would take 6 hours. Okay, and you used your equation here to figure out the values for your table. Okay? So that is number 13. Number 14, multiply each pair of numbers in the table, and what do we find out about the products? 60 times 20, or 60 times 2 is 120. 40 times 3 is 120. 30 times 4 is 120. 20 times 6 is 120. They're all equal. Okay? Now number 15. Now I didn't ask you to do 15, but I want you to do it with me as I go through graphing this inverse relationship. Okay? So it says graph the pairs of numbers in the table. So I know when my speed is 60, it takes 2 hours. So I'm going to combine my 60 and my 2 there. I'm going to do the other ones here. At 40, it takes 3 hours. And at 30, it takes 4 hours. And at 20, it takes 6 hours. Okay, so go ahead and get those values on your graph. Now the interesting thing here is that when we have an inverse relationship, our graph is not going to be a line. Okay? Now, if I were to graph these points, you see that our graph ends up being a curve. Okay? So under number 15, it says the graph of an inverse proportion is a curve and not a line. The graph does not include the origin and it does not intercept the x-axis. Okay? Now that takes us into problems with work. Okay? Work problems. Okay? When we think about work problems, we think about one person working 1 hour. We would consider that a work hour. Okay? Now these kind of problems we end up, if you end up being a business owner when you're an adult, you will consider things like this when you try to figure out how many people to assign to a particular job based on how long that job takes. Okay? So think about a situation like this. Jim and his friend can rebuild an engine in 12 hours. So how many hours would it take for Jim and 2 friends to rebuild the engine? So we've increased the number of people working on it. So if this is an inverse relationship, that means that the time it takes should be less, right? So I take my first scenario, Jim and his friend rebuild an engine in 12 hours. Okay? Jim and his friend. Jim and his friend, that gives me 2 people. They work 12 hours. Okay? So I want to find out how many hours it would take 3 people to complete that job. Okay? So my 2 people working 12 hours gives me 24 work hours, 24 people hours. Okay? So that's got to be equal to 3 times a certain number of people to give me my people hours over there. Okay? So, 3 times a certain number of hours. Okay? So it would take 3 people 8 hours to complete the engine rebuild. So 2 people, it takes 12 hours. 2 times 12 is 24. 3 times what will give me 24, and it is 8 hours. Okay. Here's another scenario. Ruffy and his friend can roof the house in 24 hours. How many hours would it take Ruffy and 2 friends? Okay, so we build a similar equation here. Ruffy and his friend, that's 2 people. They work 24 hours. Okay? I want to know how many hours it's going to take 3 people to do that same job. So go ahead and pause and answer this for number 16. Okay, so 2 people working 24 hours, that gives me 48 people hours. I'm just going to say people hours like that. Okay? So that's got to be equal to 3 people times a certain amount of hours. 3t people hours. Okay? So I got to figure out 3 times what will give me 48. And the answer is 16. So it'll take 16 hours for the 3 people to do it, what it takes 2 people 24 hours to do. Okay? Okay, go ahead and pause the video, read and answer number 17 in your book on page 630. So in number 17, they give us the following scenario. If 3 people can harvest the field in 8 days, how many people are needed to harvest the field in 2 days? Okay, so in this case, they are giving us the time and they want us to figure out how many people we need to work to be able to finish that job. Okay, so they gave us this equation, 3 people for 8 hours. That gives me 24 people, or days rather, 24 people days. So if I want it done in 2 days, how many people do I need? Okay, 24 divided by 2, that gives me 12 people. Okay, so if I want the job done in 2 days rather than 8 days, I need 12 people rather than 3 people. Okay? Okay, that finishes out investigation 9. I know this part was less than the last part, but that's okay. We've learned a lot in investigation 9. I hope you have a great rest of your day, and I will see you later. Bye.